have Thomas Rinsma, who is lead security analyst at Codian Labs and does application security evaluations and also does other interesting stuff with JavaScript, like running Tetris in a PDF. And he's telling us now about escaping a misleading sandbox, breaking the WebAssembly-JavaScript barrier. So take it away, Thomas.
Thank you. All right. Thanks, everyone, for getting up this early for this. So I'm going to talk about the WebAssembly-JavaScript barrier, as I called it here. Basically, the interface between a WebAssembly module and the outside world. And what that exactly means, we will see. So first, a little bit about me. I'm, as was said, a security analyst at a company called Codian Labs. It's a small Dutch pen testing firm, I guess. We try to do a bunch of things, but nowadays mainly application security testing, and that's a lot of modern web stuff, and hence it's gotten me more and more interested in weird JavaScript stuff, and hence I get to things like what we will get to here. What I especially like is try to dig a bit deeper than normally, I guess. So lately I've been looking at specification, actually looking at the implementation of some stuff in browsers. Sometimes interesting things pop out. So, WebAssembly. If you are not familiar, super quick introduction. So WebAssembly is a very limited execution environment within, originally at least, within the browser, so within web apps. It's, I guess, a form of assembly in the sense that it's very limited instruction set. You only have very basic types, and hence it's quite easy also just as a compilation target for many native languages, and that is the main benefit, and that's what people mainly use it for, to compile existing software and run it on the web. What is interesting, especially for what we'll get into here, is that there is no standard library. So there is no functions or anything from that are available to you by default. The only thing you can do from within WebAssembly is just compute with some numbers or use imports that are given to you by the outside world. So within JavaScript, if you instantiate a WebAssembly module, you have to give it a set of usually its functions that it can then call, and these are called imports. And then exports is sort of the inverse, where the module itself has a bunch of functions and maybe globals and things, and it can export one or more of those to be called by JavaScript. So that means that by default it has no access to the DOM or to any of the JavaScript stuff you might be familiar to, so there's no way to deal with objects even, or strings or anything like that from WebAssembly. It all needs to be provided to you by the layer of imports. So this is where the word sandbox comes from in the title, or it's in quotes at least. Because I think this needs some clarification. So this is a quote from the WebAssembly security page, semi-official, I think, where they state that applications execute independently and can't escape the sandbox without going through appropriate APIs. I believe they refer to imports here with APIs. Because in essence, this is a sandbox, right? If you have a module, you can treat this as a security boundary, where if you have some code that is not fully trusted or fully untrusted, in principle, if you compile that to a WebAssembly binary, you can limit what it does by not giving it the imports, not giving it any dangerous imports, right? So in that sense, it's a sandbox. So that's what we will be talking about here. So we're not going to be talking about the browser sandbox, as in preventing code from escaping the entire browser, right? Which is also within the web world. That's usually what the term sandbox means. So just to clarify that ahead of time. This is a bit more about that. So you can see some parties like Cloudflare and Docker also realize that this is kind of so the sandbox that I mean, that there is sort of a a nice way to limit or to provide a security boundary using these imports. And this is the threat model that we will be using, where the WebAssembly module is malicious, or maybe it's a plugin or something and you don't fully trust it. And in this case, we're going to be trying to escape from that module into the outside world. So if you're not familiar, super simple example of how this would look using WebAssembly. So there's this API, instantiate streaming. It's a variant. You give it the binary, the actual module, and then you give it an object, which is called the import object, which has these imports that I was talking about. And it's a very specific structure. So on the top level, it's just an object, but with every property is a namespace. And then within each namespace, you can have one or more imports. So it's always these two levels. So in this case, ns-logger is just a function that logs its parameter to console. And this is then what our module looks like from the WebAssembly side. So this is a text representation. It's a bit more readable, I guess, or yeah, semi-readable. So you can see that at the top there's the imports. So we import ns-logger. We say it's a function that takes an integer. And then in the main function, which we also using start, basically tell it to automatically call that main function when the module is instantiated. And in that main function, we call logger with this parameter 42. And indeed, if we then look at the browser console, logger is called with 42. So basic use case. So that's all fine, but then how does this actually work? So at some point I became interested in, the module has this, there's a list of imports at the top, things that it wants to be able to access. In the JavaScript world, there's this object with imports that are available. How are these two mapped together? So I started looking at the WebAssembly-JavaScript API living specification, where it has a whole bunch of very specific steps, and this is a small snippet of it where if you're familiar with JavaScript specification language, this capital G get is basically just property access on an object. So what it's doing in a loop is for every import that was desired by the module, it's going to be trying to access what they call module name, but this is just what I called ns, the namespace, in the import object, and then a component name, which is the actual import in the thing it just got. So basically, it's just a double property access, what you would expect. But to me, that immediately started raising some flags, because if you're not familiar, in JavaScript, there's this thing called the prototype chain. So JavaScript has a sort of special way of inheritance where, for example, if you have any normal object, you can call .toString on it. And this is not because it has its own property toString, but because it inherits that from the object prototype. So all objects in principle inherit from the object prototype, giving them all these sort of things by properties like methods and maybe constants for free. There are various prototypes, like there's of course array functions in the array prototype, and you can have a chain as well. So the array prototype has a prototype itself, which is the object prototype. And this is sort of interesting because it all happens implicitly. So when we create an empty object X, and then we try to access the property toString, it looks like it just has that property, as if it's its own property, but it's just taking it from the prototype. And same for the array example. And if you're not familiar, it might look a bit weird, but the bracket property access is just a different notation for dot notation, basically. It's all just property access. And we can see that the toString property of this empty object X is equal to the toString of its prototype. So it's the same thing. Anyway, so why is that relevant? So back to our import object, it is also just a regular object. So it has a prototype. So is ns really the only namespace at the top level, right? Does it mean that we have these hidden namespaces, quote unquote, in this object? Yes, is the answer. So if we take a REPL, so like Node.js, and we take our import object for tab, then you can see that these are all the properties that we can access on it, on top of this ns that we explicitly defined. So basically it means that we get all of these as namespaces to then import stuff from in WebAssembly, which is weird at least, and probably not intended. So I think this summarizes it well. So let's take a look at an example. So if we take the namespace toString, and then in it we take the constructor import. So this is just a property of the toString property of the import object, which is referring to the function constructor, which is capital F function global in JavaScript. We try to import that. So we just add an import. In this case, we don't define it to be a function, but we just say it's a global with extern ref type. Extern ref is just this opaque type saying this is a JavaScript thing. We just want to import it. And then I slightly modified the import definition of the logger to take an extern ref parameter instead of an int. And then we just take that oops, and we pass it as a parameter to logger. And indeed, if we run that, we see that we get this function that we were able to grab and then pass back. So this proves that we can import stuff from the prototype. So we basically, at this point, I figured we need to make, or I need to make the most of what we have here. So what exactly do we have available to us, and how can we use all of that? So it felt a bit like Mark Watney in The Martian, where we are sort of stuck in this maybe literal sandbox, and we have all these pieces of technology, and we want to be able to escape. So the end goal for me was to run eval, to run the escape, meaning execute JavaScript code. Eval itself is a bit tricky to get to, because there's not really anything's property. But we already saw that we have the function. We could import this toString constructor as the function, which is the function constructor, which is kind of like eval if you're not familiar, that you can just give it a string of JavaScript code, and it's just one step of indirection because you then have to call its return value. And as I said, we can import this function constructor, but the problem is that we cannot create strings, right? There's no string construction mechanisms in WebAssembly. So we can call this thing, but we can call it with an integer, and that's it. So that's a problem. And the other problem is that we can call it and we get the return value as an extern ref, but we can then not call that because there's no way specified in WebAssembly to call functions or external functions dynamically, at least. So these two things we need to solve. And the only way to do that is to import more stuff. So let's get a lay of the land of everything that we can import. So basically everything we care about is on the second level, right? As I said, you have the namespace, and then the actual imports are properties of those. So we look at all the properties we have, and then we care about their properties. So all of these properties, like has own property, is prototype of, etc. And these are all just functions, methods. So they all have the same properties, like which are the ones they inherit from the function prototype. This stuff is a bit confusing. If it doesn't make full sense, don't worry. So then there's also the proto property, which refers to the object prototype itself. So that gives us all of the stuff above, but on the second level. Maybe interesting. And then there's the constructor property. And this one is super interesting because it's also a function, so it also has all the same stuff like apply. But it also refers to the object constructor, which is capital O object global, which has a bunch of static functions as well. And why is that relevant? Well, it turns out that instance methods, so all of these other ones, like is, prototype of, those are all useless because we cannot really, well, we can call them from WebAssembly. Here's an example showing from JavaScript where you take this toString, for example, assign it to y, and then try to call y. It will fail because we don't pass this actual instance, this parameter. And the same thing happens from WebAssembly. There's no way to specify this. It will be null or undefined. So we are stuck with all these static functions in the object global, so the object constructor, which are the following. So we have quite a few to work with. So let's get started. We need to solve this primitive, create this primitive to call functions dynamically. We have this function reference that we created, or will create, and we need to call it. As I said, it's an opaque type. We cannot do anything, but we can only pass it along. So what is the solution? Well, we need to pass it to something that then calls it for us. And it turns out there's exactly one function in the object constructor that does that, which is group by, which is a relatively new API, I think 2024. Only recently got added to all the browsers. Basically, it iterates over this first parameter, which is an array, and it calls the callback for every item. So if we have any array with just one item, we can use it to just call, or indirectly call this reference. And I'm showing this in, I will show a lot of things in JavaScript, like pseudocode, but yeah, we're going to be doing this from WebAssembly with the imports. Then the other problem was constructing strings. This will be the hard problem, as we will see. So there's no string type. We need to somehow import something that can construct strings for us. The obvious solution is string from jar code, which you may be familiar with, just like Python's CHR. You know, it takes an ASCII value, turns it into a character or a string. So this is what we really want to get to. But it's, of course, in the string constructor, it's not one of the things we can import. However, we can get to it indirectly if we have any string, like foobar, doesn't matter, and then take its constructor property, which is going to be the string constructor as well. So two property accesses. But this gives us a couple new problems. One, we have no strings at all, so we still need an initial string. And two, we need a way to access these properties to get to from jar code. So, again, zooming in, problem, getting an initial string. Turns out this is quite easy to solve. So I did it in these 3 steps. There might be another route as well. But what we can do is we can import constructor.prototype, which is a different way to refer to the object prototype. So it's basically just an empty object, the prototypical object. We can then call object.values on that, giving us an empty array, because it has no enumerable properties. We can then call getOwnPropertyNames on that array, giving us just one property, because the empty array only has one property, which is length. So now we always know that this thing returns this array with the length string. Problem is, it's an array. We only wanted that string, so we need a new primitive to extract the string or any element from an array. Turns out we can use group by for that as well, because we can take this array that we got, give it as the first parameter, and then use the fact that the callback is called with every element. So if we define the callback ourselves in WebAssembly, which turns out is possible, just pass a WebAssembly function reference to the JavaScript world, then it will just call our callback for every element, and we can save the one that we want. So basically, we construct something like this. This is in JavaScript. This callback, save first element, it's going to be called for every element. And group by gives both the element and the index. So we can then just store the element in a global once we see that the index is what we want. And this is the same thing in WebAssembly. Yeah, it's the same. This is then how we would call it. So this is sort of the primitive that we create, get nth element, where we call a group by on this array, and then with this callback function, which is going to be storing it to the global, which we then grab at the end. And this is then how we invoke that. As I said, this is the thing, we imported the object prototype. These are all just imports. We call values on that, and we call getOwnPropertyNames on that. And that gives us the array, where we take the 0th element. And all of this just gives us the string length. So now we have that initial string, and we need a way to grab dot constructor from that. Turns out it's relatively simple. So there's getOwnPropertyDescriptors. This function in object, which gives you all of the properties, not just the enumerable ones, but all of them of the parameter. And then not just the value, but these descriptors, which contain some other stuff as well, but also the value. And what we can do is, if we know the position of this property, there's a constructor, for example, in this list of property descriptors, then we can just take the one that we want using this array index primitive and grab it using values. So here, for example, we grab the right descriptor, which we know is the second one. So here you see constructor is the second one in the list. And then this is the constructor descriptor, and then we want, of course, only the value. So what we can do is again call object.values on this descriptor, and then take the first, because we know that value is at the first spot, take the first element. So it's a whole lot of these just poking around, extracting stuff. But then finally this gives us the string.constructor thing, which is capital S string global. And we can then use the same to grab from char code. So how to then, if we have from char code, how to grab individual characters? Well, for example, if we want to make an A, again, we can use object group by. Turns out this is the really valuable function. So we can create sort of a lambda in WebAssembly that just returns the number that we want to have. And it's sort of a roundabout way to create, because if we then run keys on that again, to create or to wrap this number in an array. And we want to do that because once we call from char code, which we call using group by, we want to give it a parameter, so that parameter needs to be wrapped in an array. And here, I mean, it was a string. It doesn't really matter if it's string or a number, turns out. But yeah, there's some steps to convert that as well. So anyway, then group by gives us this weirdly shaped object with a null byte in there because it's also passing the index from char code. It's all a bit annoying, but then we just, again, take object keys to get a list with that string, take the first element to get just that string, then again the first element to get just capital A. So this is then this solves our problem of number to character. Now we want to combine characters into a string to get to the actual payload. But as I said, we have no operations for that, so again we need to find a hacky solution. There's definitely no way to call a function with multiple parameters, so we need something to accumulate stuff slowly together to slowly build up the string. And I found only one way to accumulate things in any way, which is object.assign, which given two parameters will basically merge them into, or two objects will merge them together. The trick I used is basically to create, with an increment encounter in WebAssembly, create unique keys, then assign all of the letters to unique keys, and then we can call object.values on that again to get close to our string, if it's hello, for example. Then the final problem is how to join these together. So there's various ways to convert lists or arrays to strings, to call toString basically. But the problem is that they will always put commas between every character, and you cannot create any useful payload with a comma at every other index. So I needed to find a different way. Turns out there's this obscure function string.raw, which is sort of the behind-the-scenes implementation of raw template literals. I think, I don't know the full details, but basically if you give it an object in this shape, so with this key raw, which is then a list of things, and it doesn't matter that these are individually wrapped in lists because, no, it doesn't matter. Basically, it's going to just merge that list together without any delimiters. So this is perfect for us. We just need that object with the raw key, but again, we can easily create that using group by and a small lambda. So that solves everything. Now we can create strings. But we have one problem that remains. This is the same code in Firefox and Chrome, but it's giving a different result. So there's no specification that says what the order should be of these properties in the list of property names and the list of property descriptors. So we remember from before, when I just took the first element and then the second, etc., we don't know these indexes ahead of time. So we need to find a way to either hardcode this for all the different engines. Well, it's only 3, but still. I found it way more fun to actually bootstrap this in a generic way, in case there's an update or, I don't know, a function gets added. Turns out there's a bit of a roundabout way to do this. So what we can do is we can take the length property of the length string. Remember, we had this from before. This is going to be a descriptor that looks like that. It has value 6 and then a bunch of booleans. We don't know where value is in that descriptor. We need to find that out. But what we do know that the length of length is always 6. That is always the case, never going to change. So what we can do is we can find the value in this list that is 6 and not one of the booleans. And then we know the index of value in this descriptor. So it's sort of a reverse of this get array element index thing, but then we look for the index of a value instead of vice versa. So now we have a way, now that we know where value is, we can grab any string's length, because if we know it's at index 0, for example, the string y2025, we can grab its length by getting its property descriptor, so of length, and then just values, and then the first index, or index 0, giving us 7. So why do we want a way to get any string's length? Well, this helps us in the following way. So we can build this sort of primitive again, where if we take we run get on property names on an object and get all the property names, and then iterate over that and look for a unique length. Then we know that that is the index of the property that we want. So maybe an example to help. Say we are looking for this raw property in the string global. We know that it's the only one with length 3. So we can just iterate over these, again, using group by with a callback in WebAssembly, and then use our previous string length trick to grab the length of everyone. And then once we see one that has length 3, we know that that's the index of the one that we want. And this index in the names is the same index in the list of actual descriptors, so we can grab that numbered descriptor. So this bootstraps that whole problem. So this is how I felt after solving that. Yeah. So now this is basically popping the stack of problems all the way back up. This is a recap of what we did. So we import a bunch of static functions from the object constructor. In addition to the object prototype, we import all of those. Then using those imports and all of the things I showed, we obtain length, we obtain string raw, we obtain these two dynamically, or functions that we want to call dynamically. Using all of that, we create these individual characters of our payload, and then we use string.raw to combine them into an actual string payload. Then we pass that string payload to the function constructor, basically saying this is the function that executes what we want. Then that returns this function reference that we can then call with group by, which will finally execute the payload, which I want to demonstrate. Let me see. Perfect. This guy. Moving the right things around. So maybe let's put this like this. So I think it's readable, right, with the TVs. So this is going to be, I can zoom in a bit on that. This is going to be the HTML code we have. So it's literally, we instantiate this module, which we're using fetch from this binary with an empty import object. So that's all there is to it from the JavaScript side. And then our payload, and here I have it in text representation. Let me make this a bit larger. You can see, we won't go through all of them, but here at the top we have all of the imports. Then a bunch of globals that we're slowly filling with all these indices and strings that we grab dynamically. Then all these are some callbacks. Then a way to grab the nth property we described. Here's some more callbacks, or this is this counter mechanism to build up this accumulator. Then there is more accumulation stuff. This is the wrapper function I made, sort of to go from number to character. More helper functions. Etc., etc. Here is the actual function that creates the payload. So the payload that we will be creating using this add charcoal to object, and here you see the individual ASCII values. Is basically alert, open quote, hi from WASM, close quote, close parenthesis. So we're going to try to run that alert. And then in the main, we do all the stuff that we talked about. And finally, at the end, call group by with that function that we created to actually call it. So we're now going to open this HTML page. And indeed, there's the alert. Okay. let's see if I can. I think we have enough time, so I'll go back with some final words on remediations, etc. Which. Let me close those, guys. Yes. Oh. Skip. Bless you. So, where were we? I guess a nice recap of everything that we did. Recap demo. Okay, so final notes on what happened with disclosure and things. So I figured this seems bad, this seems unintentional, and this is a break of what seems to be a security boundary, so yeah, let's report that. I also looked a bit around and tried to find use cases of this, so people using this as a security boundary in open source software, or maybe closed source even, but having this plugin system maybe. It seems to be that this is still quite rare, so almost nobody is doing this, and especially not with JavaScript on the outside. So WebAssembly is getting much more popular also with Rust and even in other stacks, and there, I think especially in cloud usage, it's getting more popular to have this security boundary. But then this attack, of course, only applies to JavaScript. But it would apply, say, if you have some sort of, if you use Node.js on the back end and you would have a plugin system there, then this would apply. I just couldn't find anyone using this, doing this yet. So it seems the impact in that regard is pretty low. I did disclose this to all of the browser or the JS engine vendors and to Node.js guys. They were all like, yeah, okay, this is weird, this is, but it's in spec, so it's a feature. Some of them were somewhat interested in maybe modifying the spec, but that's of course super hard because you need to make sure nobody is actually using, I don't know, prototypes on their import objects for some valid reason. Who knows? So yeah, so you can still do this. I don't think it's going to be fixed or changed anytime soon. What you can do is if you are a user of this or you're a developer and you want to make sure you're safe, just make sure your import object and its properties are all null prototype objects, which solves this problem. That's a bit annoying though, or maybe you use some tool that doesn't do that or whatever, so there's another way to do this. Which is maybe a cleaner way is, and I think almost nobody's doing this, but you can split out the steps of compiling the model and instantiating it. And when you compile it first, nothing is ran yet, but then you can grab the desired list of imports. So this is going to contain all that constructor stuff in our case. And then you can check if there's anything malicious there. If there is, just don't run it. Yeah, that's it. So their full write-up for this, plus the code is in Phrack 72 as well, which is around here on the camp. The code is not in there because it was too long to fit in the print edition, but it's going to be in the digital version. So that's it. Thank you. Any questions?
Right. Any questions? We're a bit early, so we have lots of time for questions. There's one.
Yep.
Yeah. So if I understood correctly, the impact is that you let's say you have a web app, a web application that supports some kind of like plugin or like user-controlled modules in WebAssembly. Let's say that you have a game and then you can like have custom servers or add-ons. And then like from the WebAssembly you would be able to just escape into the whole JavaScript. Like it feels, I don't know, but it feels just weird that there's nobody doing that. It seems like this is one of the major use cases of WebAssembly.
Yeah, so there's a big distinction is that people often use it as a sandbox, for example, to run, say, if you want to run a Python interpreter on the web, right? You want to run Python code safely, or even JavaScript code. Sometimes they compile QuickJS, which is a JavaScript interpreter, to WebAssembly and then run that as a sandbox. And that is not vulnerable to this attack, of course, because the attacker has no control over the module itself, but only over code running in it. So maybe that is the big distinction in that people often use it for sandboxing stuff, but not. I didn't see many cases where the whole module is basically attacker controlled. I did see some cases, but there's not. It's not in a JavaScript context. So maybe in games they will do it in Rust or whatever. But yeah.
So given that, like, I would have a follow-up question on that. I don't know exactly what's the state with I want to say memory corruptions, but like similar exploits on WebAssembly code, but I have experimented with some of that. So in theory, if you have one of those secure WebAssembly modules, but then you find a way to kind of redirect to some arbitrary execution in the WebAssembly, you could use that to escalate.
Then you could not use this because the list of imports is static.
Right.
So it's kind of like ELF. It's just in some separate section. It's not dynamic. So yeah.
So thank you for your talk. I just have a quick question regarding the prototype chain of the object. So do you know why the define getter, lookup getter function were not defined inside the prototype chain, or?
They were indeed. I skipped over that because in the REPL autocomplete they're just not printed anymore because they're deprecated. I did play with them, but they're also instance methods. So they require, it's a bit weird to think about, but they require this parameter as well. So there's no way to invoke them. So I even tried to get to the apply function to put or call or whatever to pass the this parameter, but even those themselves are you can only call using dot notation with a this parameter. So this is a very much a chicken and egg problem. So yeah, they were there but not useful.
Okay, thank you.
Yeah. Oh.
Did you attempt to do this outside the browser? I know there's some outside the browser WebAssembly implementations. Maybe some of them use JavaScript objects for their imports.
So the question is if this applies to contexts outside of the browser.
Yes, if maybe you tried it.
Yeah. So this exact same payload will work in Node.js because it's just V8. It's the exact same. Maybe the threat model is a bit different. So with Node.js, there's a fun. So there's something called WASI, W-A-S-I, which is sort of a standardized set of imports or various parts that you can plug and play of imports to run WebAssembly modules sort of by themselves, sort of POSIX-like. And there's also various sandboxing efforts there where you can say, I only want to give it access to these directories or whatever. And Node.js tries to implement that. But of course, they have all kinds of logic that you can say, WASI generate import object. It's going to give you this whole import object with all of this logic, but it has the object prototype. So all of this sandboxing stuff, you can just, using this, bypass that. I did mention that to them, but they said, yes, look at our documentation. There's a big banner saying it's still experimental, so we don't care. So, yeah. But other language stacks, this doesn't. So in a Rust host, this doesn't apply, of course, because this is all JavaScript tricks.
First, thank you very much for your talk. So I wanted to know if you ever tried to implement anything like HTML smuggling with this technique, because normally for HTML smuggling, we need to execute some kind of a JavaScript code into some like a web page that we deliver to the target to deliver some kind of a file. But like with this technique, maybe we are able to deliver the file in a more obfuscated way to the users, but I'm not sure if you have ever tried to.
Not sure if I get. So you said HTTP smuggling? Or?
HTML smuggling. So yeah, we deliver a HTML file to a user which contains a malicious file or anything inside it, and when the users open it, so it automatically like a.
To use this for obfuscation and things, you mean? Or?
Yeah, to deliver the actual file to the target.
Yeah, I mean, it might be a nice trick because WebAssembly is a bit more difficult to debug. In the browser tools are kind of behind on that, I think. So yeah, if you want to use this for DRM or whatever, it might be useful. Yeah.
And with this technique, are we able to access all the DOM objects
Yeah, so I mean, we just have eval basically, so we have everything. So it depends on the CSP, I guess, a bit. But yeah, we can do everything you would be able to do from JavaScript.
Great, thank you.
More questions? No, then, well, thank you, Thomas, for this very...
Yeah.
This very thorough run-through of the assembling functions out of functions.
Yeah, so indeed, feel free to read it at your own pace later. That might make more sense than trying to follow along.